What's up, YouTube? In this video, we're going to be looking at Azure DevOps Build Pipelines. Now, in the previous video, we talked about Azure Git. So I'm assuming you have a repo in Azure Git. In this video, I'm going to be talking about automating the build process. And the build process could mean many, many things. But in Azure DevOps, it's just called the build pipeline or the CI pipeline. And so that's what we're going to be talking about today. In the course of this video, I'm going to be talking about a whole host of things, such as the hosted agents or custom agents and variables, custom variables, predefined variables, build tasks, and on and on. So this video is going to be really interesting for those of you who are looking to build or automate your build process in Azure DevOps. All right. Now, the project for today is decently complicated. So it's not a toy project. It's a fairly decent sized project, and it has some complexities in the build process, which is why I chose to use this project in today's video. I'll make the complete YAML file, which is the definition of your build pipeline, on my Git repo, and I'll put a link down below in the show notes. So here I'm going to be discussing the different pipeline parts of the YAML file and go into depth wherever I think is necessary. Just to give you an explanation of what this project is or what it comprises, it's a .NET Core project, but it has a database project, which is not .NET Core, is .NET Framework. And my tests require the database, which implies that during my build process, not only do I have to build these different projects that are from different frameworks, but also I got to somehow manage to deploy a database on the build servers in Azure DevOps and connect to this database, and then my tests can access this database and function completely. So that's the complexity. It's sort of a multi-platform, if you will. .NET Core and .NET Framework was not multi-platform, it's multi-SDK. But it also, that complexity is adding some twists and turns. And then the database itself, the fact that you have a database and you require a database to automate your build process, that makes some things a little more complex. Now, in Azure DevOps, the build pipeline, I could sometimes say build pipeline or the CI pipeline, it's one and the same thing. In Azure DevOps, they actually call it the build pipeline, even though they're talking about continuous integration, they keep saying build pipeline. So either way, I think they're sort of synonymous in this particular case. So what is the purpose of a build pipeline? Essentially, you're trying to automate your build process. Now, in some cases, the build process may be really simple. You just build your project and you run your tests and everything's good because your system doesn't have dependencies that may be generally missing on a clean machine. By clean machine, I mean a Windows machine with a Visual Studio on it. That's it, right? If your build process requires other software, I'm not talking about the NuGet packages and things, I'm talking about other things. Let's say you're using RabbitMQ. Let's say you're using an Azure service. Let's say you're using a database. Let's say, what if you are building your system on Azure DevOps, but the dependency is on premises, which means you need to be able to come into your network from the outside, from Azure DevOps to your on-premises services. All of these features and capabilities are provided in Azure DevOps, and I'll go through each of them one by one, including if you don't want to use a Microsoft hosted agent, which is a build agent on Azure DevOps, you can actually host that. You can have a custom agent on your premises, on your local machine. I've done that. It's fairly simple to get started. I was actually pretty amazed by that whole process. It's been a while since I did that, but that was certainly an eye-opener as to how easy it can be to have an agent on premises and have a pull request being accepted on Azure Git that triggers off a build that calls back into some machine on your local network and starts the build. But in this video, we're going to be only talking about the Microsoft hosted agents and show you the YAML. I'm not sure the YAML would change for any reason. It's just that the agent will change in your YAML file and everything else should be the same. Okay, so to get started, I'm going to just navigate to my Azure DevOps account. And so they call this the organization. And then these are called projects, even though from a Visual Studio Parallels perspective, this is not in a solution. It's even higher up than a solution, but they call it a project in Azure DevOps. So if I went to this project, in the repos, I can have n number of repos here. I only have one for now, but this repo is synonymous to a Visual Studio solution. So just keep that in mind so that you don't get confused, because unfortunately the terms are the same, but they have different meanings for us in Visual Studio versus in Azure DevOps. So this is a solution, and as part of my source code, I have this YAML file. Now, the extension is YML, the acronym is YAML, and it used to be called yet another markup language, but it seems the folks at YAML have decided to call it not yet a markup language, but YAML ain't a markup language. I call it YAML. It's just simpler. So this is what the YAML file looks like. What can you do with this YAML file? A whole host of things you can do with this YAML file. It seems a little complicated. Azure DevOps didn't used to support YAML before, so it's a relatively new feature in Azure DevOps. It used to be a more visually oriented way to build a pipeline or to configure a build pipeline. Now it's mainly YAML based, but you can resort to what they call the classic build pipeline, all right? But we're going to be talking about just the YAML file. So if you go into your repos, into your pipelines, you'll see the different pipelines you might have configured for your repos, and this could be to different repos. In this case, it's only configured to the one. And what branch these pipelines are for. In this case, both of them are associated to the master branch. So if you want to create a new pipeline, you'd come here, and then you'd pick the source of your source code, or you could switch to the classic editor. In the classic editor, as I said, things are a little more visual. So you're going to do the same thing. You're going to choose the source. And once you choose the source, the next thing is choose the kind of project, if you will. So you could say it's a .NET desktop app, or a ASP.NET application, or a ASP.NET Core application, or a ASP.NET Core .NET Framework application, etc., etc. So this project is an ASP.NET Core .NET Framework application. I hit apply, and what it does is it builds up this pipeline. It's pre-configured certain tasks, and I'll explain what these are, the tasks and things. But for this specific, the build solution part, there are various variables or parameters you can set up, and each of these parameters, of course, will mean something to you in your project or in your solution. And I'll explain to some extent what each of these tasks are and what their parameters mean, so you can get a full sense of those tasks. But also there are a whole host of build tasks in Azure DevOps. We're only going to be covering a small portion of it. So it's something you have to experiment with or explore. So now, even though this is a visual way of adding tasks to your pipeline, you can look at here. This is the pipeline, and that's the name of the pipeline, and the agent pool, and so on and so forth. And then for each agent, there's a job, and for the job, there's different tasks. All right. So if you wanted to look at the variables for your pipeline that are set up over here, some of these variables are sort of pre-configured, and some of them are custom. So there are, in Azure DevOps, as I said, there are pre-configured variables that you can use in your builds or in your tasks, and you can define your own variables, and you can use those as well in your tasks. There's a whole list of predefined. It's not just these, but there are some of these that are just kind of there by default. All right. And another interesting one is the system.debug, which is typically set up to false. So going back to your pipeline, you can also add new tasks, or for every task that you click on, you can see the parameters or the variables or parameters that have been set up for each of these tasks, right? I won't spend too much time here because the equivalent of that is the YAML. You can look at any one of these jobs and then get the YAML for that here. And this essentially is the YAML for everything that we see here on the left-hand side here. You can see there's steps and there's tasks, and there's the NuGet tool installer, which is that. There's the NuGet restore happening over here. Then there's the VS build over there, and so on. So each of these visual elements are essentially converted back into YAML. Right? So you can copy this and start from there. Or you can start, I'm just going to go back to my pipelines. I want to say new pipeline, I can pick my repo. In this case is from Azure Git, and that's the repo. And then I can pick ASP.NET Core Framework, and that's the YAML, right? Now from here, you could also visually go back here and say, okay, let me search for, let's say, for example, if you want to look for MS Build. So you can search for MS Build and you can pick this task and drop it in there. When you click on it, it actually puts it wherever the cursor is. You can specify the different arguments here. When you say add, it's just going to go into the location where your cursor was, right? So there's many ways to get there. Some is visual, some is hybrid. Either ways, I suggest if you're starting off, even though it may seem a little complicated, just stick with YAML, since that's the sort of the future on Azure DevOps. It's not going to go back to the visual part. It's going to eventually deprecate the visual side of things. But this is semi-visual anyways here. And that's how you would create your new pipeline. So I'm just going to skip this step, go back here. So it's not going to save it. So I've got a couple of pipelines set up here. Once you set up a pipeline, and this is essentially showing your pipeline has succeeded building the solution. In this case, both these pipelines are actually working. I'm going to pick this one here, and then I can just go back and I can edit this pipeline like that. These menus, if you're not familiar with Azure DevOps, the menus are hidden in some ways, as in you may not know to look here or there for a certain menu option. So they have them set up over here. See, by default, you don't actually see it until you move your mouse over it. And then you got these menus over here to allow you to handle pipelines. So I'm going to go here and I'm going to go into edit. I can even run this pipeline directly from here. So it starts a whole nother build process. Or I could go into edit to look at the YAML. So as I said, there are a build pipeline or a YAML file is comprised of multiple steps, and each step has multiple tasks. It also has jobs, and a job has multiple steps, and steps have multiple tasks, and so on. So it can handle quite a bit, YAML can. But typically in our build pipelines, in our release pipelines, we don't need to get that complicated. So I'm going to step you through each of these tasks that I have here, explain some of the pros and cons and what you should look out for if that applies to certain tasks, but you'll get a sense of what is going on in these YAML files. So essentially, we're going to be picking a hosted agent. This is a virtual machine, in this case, hosted by Microsoft. So they call them Microsoft hosted agents. And these agents are virtual machines. Depending on the agent you pick, they have various software pre-installed on them. Now, that's not to say that they have software that you may require, but they each come with a certain set of predefined software, such as Windows, if you pick a Windows agent, Visual Studio, Node.js. This is a whole list. So if you look at the different agents, if you go here, there's a website for all things Azure DevOps related and Azure DevOps pipeline related. So you can see here a whole host of things. So I'm here now in the Microsoft hosted agents. There's a list of agents here, and I typically use in the previous editor, in the classic editor, used to be called Windows and 2019. And YAML, we call it Windows latest, and of course this might change. Today's Windows and Visual Studio 2019, but tomorrow it could be something different, another version of Visual Studio. And if you click here, you will see the different software that is pre-installed on this VM. Now, the reason they have it, of course, is your builds may require other software, or if you need to install additional software. Let's say you got your own, third-party thing that needs to be installed on your build servers because your software relies on it. Then you have the option as part of a task to say, okay, first go install that software, then go build the solution, right? So you have these various tools here, such as Chocolatey or PowerShell, and there's a bunch of Docker images, and of course, Visual Studio 2019 Enterprise, and on and on and on, right? So every hosted agent has different sets of software included. So you might want to look at each of those to decide which one you want. And you also have the option to use Ubuntu or macOS as your build agent in Azure, right? So those are the agents. If you look back here, the first thing I'm setting up is the trigger for the build is the master branch. And the way I've set up the master branch is anytime a pull request comes in and the code view is approved, then it automatically kicks off a build. And that's a choice you have, whether you want to make that automated or not. But those are some of the features in Azure DevOps. You can also have emails sent out to specific people or all the entire team. Every time a build starts, every time a build succeeds, every time a build fails, and so on and so forth. So there's lots of automation available and notifications available to these automated steps in Azure DevOps. I'm not going to go into the details of that, but those are easily discoverable. And I don't think typically people get stumped in that area. Most people get stumped in the YAML file and the build process and how to set up the build pipeline. So that's the focus of this video. The trigger can also be different branches. So maybe each of your devs is creating a new branch when they start. You could set up a build for each of those branches so that when that branch is, the pull request is accepted, it builds on that branch, and that pipeline could be different for that branch versus the master branch and so on. So there's lots of configurability and variations available in Azure DevOps. The agent, they call it a pool. The agent is the Windows latest. All right. And so this is a pool, and these are the variables. So some variables are predefined, and you can add your own variables here. So you can give it whatever name you want and any value you want. And then the way you use the variables in your YAML files is $pren and then the variable, the name of the variable. Right? So anytime you want to use the variables, you just put in the $openpren, put the variable name in there, and close pren. All right. Now the same parameters are available through a DOS prompt. So let's say you need to, as part of a build process, have a DOS or batch file run for whatever reason. Maybe there's a feature or functionality required that's to be installed or set up on the local machine that requires you to use a batch file. So you can run the batch file as part of a step or a task in the build pipeline. And maybe in that batch file, you need to access some of these variables. You can do that as well. You can do that from PowerShell. You can do that from batch files. You can do that from bash scripts, and on and on. So the same variables, the names change a little bit, but the same variables and their values are available not only in your YAML file, but also in batch files, in PowerShell scripts, and in bash files. All right. So I can show you that. So we have some of these predefined variables here. Again, I'm just on a Microsoft page here. I'll put some of these links in the show notes below, so you can go directly there. So you don't have to go searching for it. But it's very valuable, the information in these various pages on Microsoft with regards to Azure DevOps. I suggest you give it a read. You'll gain a lot of insight as to how things are working and how things are configured and how to even debug your build process. I'll talk a little bit about how to debug your build pipelines, but I'm not going to go into a whole depth of that. So the pages here will actually help you with some of that. So there are predefined variables such as system.accessToken, system.debug, agent.build directory, agent.home directory, and so on. And you might need some of these variables when you're trying to, let's say, determine the path. So let's say you need to do something in a DOS, in a batch file. What's the path? Like, where am I at? And where's the solution? And what's the path for that solution? So all these variables will give you that information, so you can configure or make your PowerShell scripts or your batch files and make them actually work, being independent of your Visual Studio parts. So there's a bunch of predefined variables, and there are also variables that are build pipeline variables, and some are release pipeline variables. So today we're only talking about the build pipeline variables. So they do distinguish between the build pipeline variables and release pipeline variables. And of course, custom variables are things you have of your own. Now, if you're trying to use some of these variables or any of these variables from your, let's say, batch files, then they become capitalized. And of course, in typical DOS fashion, they'll have % signs on either side of them. So the dot gets replaced with an underscore. And in DOS, you would put % signs on both sides. If it's PowerShell, you'd put the env, $env, openpren. But the name changes in all cases to uppercase underscore. So whether it's a bash script or a PowerShell script or a DOS script, they all change the name to uppercase, and the dot gets replaced with an underscore. And of course, the syntax is going to be based on that the DOS file or the batch file or the bash file or the PowerShell script, where that dollar comes, or do you put env and so on and so forth. So that's all part of that environment, but all the variables are available to you there. So in this case, the first thing I'm doing, and this is just for demonstration purposes, I don't actually need this task in my actual build process, but I'm showing you that there's a batch script task. You can simply copy this and go search for this in Google, and you'll get a whole host of information. Or you can look at the catalog, as I show you here, the build and release tasks. There's a whole catalog here for build tasks are different from release tasks. And the entire catalog you can look at by expanding things out. And you can see a whole host of information here. So if I want to look at .NET Core CLI, this is one of the tasks we actually use in this build task I'm going to show you. And so that's what it's described as in the YAML file. And these are all the possible parameters. Some of their default values, some of them are either optional, even though they're optional, they'll also specify the default value. Like in this case, it's going to say publish test results. True is the default, but it's optional. You don't have to specify it. So it's going to be true. But if you don't want it, you're going to have to say it's false. So each of the tasks have a whole host of documentation. If you know the name of the task, you can just copy it and search for it, and you'll end up on a file like this, on a page like this, I mean, right? So going back here then. So what would happen in this batch file is that it would execute another batch file. And I'm saying if there's any errors in this batch file, then it should fail, as in this should not continue on. You can look at the batch file here. So we have certain variables here, the build configuration and build platform. If I go into the repo, you'll find there's a batch file over here. If I look at the batch file, this is what it looks like. So it's essentially pulling out the variables, the predefined variables that we have access to. And as I said, in DOS, you're going to say %, and then the dot gets converted to a underscore, right? So I'm just testing out the different variables and their values. And in this case, I'm also saying I want to see the folder contents. And this sort of thing comes in handy when you are initially setting up your pipeline, because you may not understand the folder structure, and do you go 2 folders up from where you are to get to that other file, or is it 2 folders down, and so on and so forth. So this sort of thing, the agent work folder, the build directories, the source directory, all of these things will help you understand the environment on that build machine, on that VM, and then you can figure out how to get to the stuff you're trying to get to. So this is a nice way to figure that out. So I'm going to leave this in the file I put up on GitHub. So in case you're starting out and having trouble, some of these values are going to help. And you're going to see when this build pipeline runs, the results of that. And we'll take a look at that as well. Okay, back to the pipeline. Okay, so now the first thing we're going to do is build our solution. Now, in this case, I'm using VS Build, and I'm telling VS Build to restore all NuGet packages and build the solution. So the solution is whatever SLN file you can find in that folder. If there are multiple solutions in the same folder, then you're going to have to specify which one. And I want it to be a clean. I wanted to use the maximum number of CPUs available, and I wanted to use build it as a x64 architecture. The next step is now, if you remember in my case, I said before I can run the test, I need a database. So in this case, it's SQL Server or SQL LocalDB. And that's another feature that's pre-installed on the virtual machine, which is SQL LocalDB, which is the command line for SQL LocalDB. And that command line allows you to create a new instance, give it a specific name, spin up the instance, and then you can also, if you have a DAC pack, which I do in my case, I can hydrate that database on the build server, and then I can run my test. That's what we're going to be doing over here. So I use the SQL LocalDB, and it has a command line feature. So I'm saying create an instance by this name, and then start up the instance. Now, there was a time in Azure DevOps where even SQL LocalDB was not available, So it was quite a bear trying to get that to work, but I'm glad they've now given us the feature where SQLDB is pre-installed on the machine. When I logged the complaint or the bug report with them, they said it should be there. I said, well, it's not. And then a few months later, it appeared. And so now I'm able to make it simpler. So I'm using the command line here to just do that, right? Now, once the database instance has been created and the database instance is started, I can then use a task that they already have now called the SQL DACPack deployment on machine group. And that's the full name of the task. And it requires a DACPack. Now, DACPack is the outcome of a build of a database project in Visual Studio. Just like a DLL is the output of an assembly, or a exe is the output of an application executable. The DACPack is the build version of a database project. So it's not like it's weird. If you haven't used that, then that's what a DACPack is. And so you see here, I have to figure out how exactly do I get to my DACPack. And so initially, of course, when I didn't understand how this was working in Azure DevOps, I had to use that test.bat kind of thing to figure out where is my directory and then how do I navigate to my DACPack from where I am. And so that was the build source directory, and that's the path to my DACPack. And then I also have in my database project, and this is not necessarily for Azure DevOps, this publish XML file, which is something you would have when you're using database projects in Visual Studio, is to deploy the database, let's say on a local machine. So there's a publish XML file, and you can have n number of these publish files. So I already had the publish file. So I'm just using the same publish file to then publish my database to that instance that was just stood up. And the reason I do that is because I also have a post deployment script, which seeds the database with certain information, certain data like lookups and things like that. So I need to have this XML file executed, or the publish script executed, so that it does the builds up the database and also runs the post deployment script. Again, this was not required just for Azure DevOps. I needed it anyway on my local machine and to run my tests and things on my local machine. So it was already there. So I'm just using the same thing. So that's the publish profile. So now by this step, the database instance has been set up and started. By the end of this step, my database schema has been hydrated in the database, and the database has been populated or seeded with certain data. And now I can actually run my tests. So in order to run my tests, in this case, because it's kind of like a hybrid thing, I'm not using MS Build, even though I could have used MS Build for this. I'm not sure why exactly I stuck to using .NET Core CLI, but I've also used MS Build for this. It really doesn't matter. But .NET Core CLI has different commands. One of them is test. The other commands are build and package and a whole host of other commands. So when I do test, now the default behavior is in .NET Core CLI, when you do test, it's going to do a build. But since I've already done the build in the previous steps, I don't want to do a build again. In the Azure DevOps, you are charged for how much time your builds take. And I think they give you, and please don't believe what I'm saying here in terms of the actual numbers, but I think it's 360 hours or 36 hours or something like that of free build time across release builds as well as builds, right? Your CI and CD. So of course you want to make sure your build pipelines are optimized in that they're not wasting unnecessary amount of time. So I don't want to build it again. So in this case, they have a parameter that you can set to false so that it doesn't rebuild the solution that's already been built. Now, because I have to build the solution first because I need that DACPack. So I can't just do a test where it starts the build and runs the test because I don't have a database yet. So I have to break it up in multiple steps. So that's this step, which does the actual running of tests. And some of the arguments here to the test are things like the run settings file. This is again a Visual Studio feature. I'm using it here because I wanted to ignore from a code coverage standpoint the test projects. I'm not interested in getting code coverage for the test projects. I only need the code coverage for the actual project. And then the switch for the logger, which is the actual coverage file, code coverage file, and then the argument that says I want to collect code coverage. So these are typical MS Build arguments, nothing specific to this task, but they're also available on this task. So I put these arguments in there in the argument section. I'm telling it This task actually needs DLLs. So, or project files. It's not, so you have to tell it what project files. I'm sort of using a wildcard here to tell it what project files to look for. And once the tests run, I then ask it to publish the PDP files to a certain path. And then I wanted to copy all the files from a certain folder to a certain target folder. And then publish the artifacts, which is essentially just a staging area where the next step, the release pipeline, can kick off from there. So your release pipeline will say, pick up the artifacts from this folder and then push it out to the servers in Azure, right? So this is the build pipeline. So I'm going to run this pipeline. Now there's a few ways to run it, and there are a few ways to debug your solution to the problem. Now you can come in here and you can say run, and there's a few options here. One is you can enable system diagnostics. Right? So that will give you some additional help or information. If something is going wrong, you can get a full detail of what's going wrong. There are logs at the end of the build. Even though the build fails, you have access to the logs. That should help you figure out what's going wrong. Or you can use this variables thing here, and you can add a variable and you call it system.debug. And you can set the value to true. Now remember to turn this off after, I think it remembers it. Can't be certain anymore. But nonetheless, if it's on, you need to set it off again. But I think this is for the specific run. So if you set this to true, then you'll get additional information at the time of doing the build. So when the build fails, you'll have a whole lot of information. So between the system.debug equals true and the previous option here that we had to enable system diagnostics and the logs, you should be able to handle or figure out what exactly is going wrong. The complexity comes only, of course, if your projects are super complex, meaning they're not the normal structuring. If things are kind of out of the path, they're not in the root from the root of the solution onwards, but they're kind of out of that root, or you have a bunch of dependencies that you install. And so that complexity might add to problems, but by itself, it sort of just works. Right? So if you follow this typical folder structures and things in the general .NET community, stuff just works. But as I said, in my case, I needed the database project and so on. So I'm not going to pick any different options here. I'm simply going to run it. So I could run it from here, or if I went to my pipelines and I clicked on this here, or just from here, I can say run this pipeline. So there's many ways to run the pipeline. So I'll do it from here and then come back here. So same options. I can enable this, or I can use the variables. I can also pick, I guess, on what variables to, I've never actually used this, but you can pick different stages. Now I said the run is going to cost you, and it's not. This is so reasonable. I mean, I've never paid any extra money for doing all my builds, and I do a whole lot of them. But of course, you want to be cognizant of the fact that there's a limit to how many free minutes or hours you get for a free account in Azure for private Git projects. So my builds typically take about 4.5 minutes or so. So the way it looks is, and this is almost real time. It's not real time, but it's almost, as you can see, stuff is appearing in this command window over here. It's just it looks like a command window, so it's not actually a command window. You can't write commands in the window here. But you're seeing all the different jobs. You're seeing how much, these are actually tasks, and how much time, or in seconds or minutes, each of these tasks are taking. So the build takes approximately, I think, like a minute, I believe. And then it's going to create the local DB. So it took about, yeah. So I'm going to forward this on, and then we'll come back and examine the output or outcome of all of these different tasks, so you can see what that is like. All right. All right. So this build task has completed successfully. As you can see, all of them are green here. If we click on each of the individual task here, you'll see the output in a DOS command window style output. And this would be interesting for those of you who've never seen this before. This is that batch file that we ran here. So I'm saying system.debug value is false because I didn't set it to true. So there's nothing there. Hello world from hosted agent. My ID is 10. Agent work folder is that. And then the contents are all of this. So the different directories and so on and so forth. So this is going to sort of help you decide or figure out where exactly are you situated when you run these build tasks and how to get to the actual files that you're looking for. This is the build agent directory. And then this is the build source directory. So this is essentially the root of the folder here. So you can see the YAML file is here, the batch file is over here, and so on and so forth. So once you get to this point, of course, you can navigate anywhere within your own structure because you already know that structure. That's kind of one way to debug. The other way to debug is to view the logs here. This gives you a lot more detail. Any one of the jobs you can click on and see the logs. Now here I can see there's a warning for the build process here. So anyway, this is the full set of tasks here. Now if you go back in here, you're going to see that this job succeeded. And along with this job, it took 3 minutes and 32 seconds. And now for the job's output, I can look at the test results over here. So you can see in this case, there are 40 tests, all tests pass, so the 100% pass rate. And the test took 28 seconds and 953 milliseconds. Now, in my case, I also have code coverage. Now, code coverage is not something they have a visual description for here, but I can download the coverage file, right? So I can actually download it and I can open this file. It opens Visual Studio, but it can't show you the source code. So what I'm going to do instead is I'm going to close Visual Studio again just to see that file. Where is it putting it? And I can say open and show in folder. So I can see that's the file. So I can now say open with, well, let me open Visual Studio here with the same solution. So it gets access to the source code. You could even do it the other way where you dig into it, it's going to say, hey, I don't know what the file is. And once you point it to the right file, it'll find all the other files. But this is another way to do it. You can simply drag drop this file onto Visual Studio here, and it should show you the code coverage results. So you can see the code coverage is 99.12%. And if you want to take a look at what's missing, what's wrong here, I can navigate to this location to find the culprits. And then I can actually go to the actual source code. So you can see here that this line is partially covered because in this case, there's a conditional statement. And that's another problem with this question mark dot. If you start using this, it's going to be very hard for you to get the code coverage. Now, that's not to say that you shouldn't use it when you need to, but that's one other sort of downside of that. But as I can see here, this is a partial coverage. It's not a red. When it's red, it's a full coverage. So basically all of these situations are partially covered because it's going to be virtually impossible now for me to create a scenario where the DB command is null, the transaction is null, and so on and so forth. So anyway, so that's the code coverage. There's no visual representation in Azure. In some ways, that's a good thing because Visual Studio's code coverage analysis is super. I mean, it's very, very informative and useful, and you can navigate to the actual code. So I can't imagine the same feature in Azure DevOps on a web page giving you the same functionality. So it might show you the code online, but here you are in your solution on your desktop, and you can kind of navigate where you want to and fix it and start working on the missing, in this case, code coverage and stuff like that. So anyway, this takes us like a full circle from starting a new pipeline, understanding what pipeline tasks are, variables are, agents are, having the run, and then looking at the final outcome of that task. Now, if we go back to the actual task here, you can see that this task, build task, has had so many different runs. So you can go at any point in time, you can go back to any one of these pull requests that has a build and look at the details. Maybe there's a failure. Why did it fail? Or how much time did each of these take? So this one typically takes about 4 minutes, 4.5 minutes. Today it took us 3 minutes and 38 seconds. So it's faster. All right. So I hope this has been a useful and interesting episode for you all. I hope you enjoyed it. If this has helped you, please give me a like. Please subscribe. Please hit the notify button. And I will see you next time.